last class we were discussing about the data operators. Okay. Today we see the operators. Operators in the last class we see the separate on the list of operators in the Verilog HDL for writing a data flow model programming. Okay, we can write any digital system. We can write in three ways. One is what the gate level modeling or structure model. Another is what the data flow model. Third one is the layer model. Layer is in okay. Layer is stated about the writing a program for Verilog HDL for digital system in the with the help of what the in the model we have to gate level model. Gate level model. Whatever you see the figure, okay, digital system hanging with gates name that will be used as a gate level model. But today we will see the writing a program, okay, data flow model also. For this we have seen the some basics for writing the data flow model, okay, how to use the keyword and all. In the last class we have seen about the assignment statement, continuous assignment statements, delays in the how to mention the delays in the continuous assignment statement, and also different types ways to write the delays in the assignment statement. Okay, assign keyword, which will start with the assign keyword. Continuous assignment statement starts with the assign keyword. So that we will see the how to use. Okay, for writing a program we need the gate names, what the operators. If I have the gate name as the AND, then I will go to the ampersand. That means we have the different types of operator, and also we need to express writing a expression with the addition, subtraction, and all. We need the different types of operators also. So that we go with what the I will study one more example. In the last class we see we listed all the different types of operators. Today we will see that with each and every operators with the one example, at least one or two examples. Okay, this is the very important topic and also easiest topic. You can easily score. Okay, you can easily write. You can write after all in the examination 10 marks. Definitely. While seeing the operator only, that operator what kind of operation it will perform, that you can keep it in mind. You can write the any expression. You can solve the any expression with the help of those operators operation. Okay. Now we see call say okay. Okay. Today we start with the arithmetic operations. Arithmetic. Arithmetic operators. Okay, arithmetic operators. What are the arithmetic operators? There are two types of arithmetic operators, namely binary and unary. What are those? Binary and unary. Okay, binary and unary. Binary is what the here I need the two operands. Okay, for the two operands for the binary operations, and also unary one will be using every time. But the unary operators will be performing only one operand. Only one operator will do some operations as we need go with the different types of operations also. Okay. First we consider the binary arithmetic operators. Okay. Binary arithmetic operators. Binary arithmetic operators. What are those arithmetic operators? What are the binary arithmetic operators? Addition, multiply, divide, addition, add, and subtract, and the power, and the modulus. These we listed in the last class. It is the arithmetic operators. In the list of operators, we listed all these different types of operators in the last class. Okay, we see the one example for multiplication. We use the star as operator. Divide, we use the slash. Add, plus we using, and the subtract minus we using. Power is used to the double asterisk. Double asterisk. Yes, the operations while taking the operators together. Just to take that, for example, a equals to 4 bit of what are those 4 bit of the value as 0 1 1 0 but 0 1 1 0 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ ಇದು 0 1 1 0 this is for the 2 is to 0 this is for the 2 is to 1 this is for the 2 is to 3 this is for the 2 is to 1 2 okay sorry 1 2 3 okay what is the value of this 0 means what 0 1 is equal to 2 this 2 means what 4 this 0 means what 2 how many 6 like this you can easily calculate okay even you can also write easily as 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 2 4 0 are 2 4 0 to the power of 0 is what 1 yes sir but I have taken this one as the faster than okay we are multiplying the how many times we are not multiplying 2 is to 0 for the 2 is to 1 for the power just to nothing but that 2 into 0 how many times we are multiplying here 2 to the power of 0 is the multiplication okay I have explained actually the value of this 2 is to 0 is 1 of course but thing is that we are multiplying that many times we are not multiplying value here 2 is to 0 is equal to 2 into 0 is nothing 0 2 into 1 is what the 1 2 2 into 2 is how much similarly C by D. C by D is C has the value 8 kada. Howda? 8 by 3 is how much? 8 by 3 is what the 3 to the 6. I left it what the 2. I left it what the 2. Terminate the fraction value. We will have the terminate the fraction value. Okay, just to see the C is how much here? 8 by 3. 8 by 3. It's for the cube. Okay, the terminate the 8 by 3 is how much? 3 to the 6. How much you have left there? Okay, to the 6. I left it for the reminder here. Okay, just I go to the whatever I have the email. Okay, this is for the 8 by 3 how much? 2. It's I left it for 2 here. Just to terminate this one. You can negate this value. Okay, then the C by D is how much? 2. C by D is how much? 2. This is for the truncate the fraction part. We are going to truncate the fraction part. Fraction part. Truncate the fraction part. Okay, and also I go to the A plus B is how much? A plus B is how much? A plus B is how much? A is how much? 6. Okay, 0, 0, sorry. 0, 1, 1, 0 plus B is how much? 0, 1, 0. How much? 6 plus 2 is how much? 8. 8 outright 8, 1, 0, 0, 0. This is what the equivalent decimal value. Like this we need to write. And also A minus B. A minus B. A minus B is how much? A is what the 6. B is what the 2. 6 minus 2 is how much? 4. Like this I have to write the 0, 1, 1, 0, minus of 0, 0, 1, 0. This is what the value here. 6. 6 minus 2 is how much? 4. How to write this? Value form 0. 4 is how to write? 0, 1. Sanya, what is the binary value of 4? Vega, what is the value of binary 4? 1, 1 double 0, right, 0, 1 double 0. This is for the 4, okay, this is for the 6 minus 2. Like this, similarly I can have the D double multiply. This is the double multiply with the power. This is for the power. 6, D is how much here? Look at the D is what the value of D? 3. Okay, power is what the 2, 3 is 2. Okay, this is for the 3 multiply power with the 2. What is the value of the 3 power of 2 is how much? 3 into 2, 3 is to 2. Is it not the yes, the 9. 9 is the value here. 9 is the value. How to write the 9 value here? 9 value. Okay, that's the 9 to be written as the 1, 0, 0, 1. This is not the 9 value. You should have to mention always in the binary form. Whatever the value is written, that one should be written with the. This is for the value 8. This is for the 1. Because what is for the 9 itself. Copy this one. This is a frequently asked question. Many times they are asked in the examination. Just copy it. For 10 marks. Next we go with the binary operators. This is what the fixed question. I am asking the test also. I will be asking in this question in the test also. Okay, not only this question, I will be achieving the some operands values here. Operands which are the operands? A, B, C, D, E. These are what we call the operands. Whatever we are using, these are called for the operators. These are what type of operands? Arithmetic binary operators. For the binary operation on the arithmetic operation on the binary values. this one. Okay, so we will complete our today's module. Okay, we have to for the only operators and the three examples are there. One for the first 1 marks in the writing program, the data flow model, for the first 1 marks school ladder, and also for the SR latch. This whatever we return the program for the programming for these examples in the data flow model. Sorry. For the data model, similarly we can write the these different types of digital systems in the what the data flow model also. If I have the one operand, if I have the both operands are given here. If my operand is consists of only one unknown value, x value, then definitely the value of the output is also the operation is what the x is also unknown. For example, int one example is equals to not 1 4 bit of 4 bit. This is what the 4 bit 4 number of bits with the binary. Now one by 2 bit to 2 bits. Okay, 2 bits of the that's the value. If not d put to the decimal output. Now b put to the binary 0 or 1 to the student. Okay, 1 0 1 x. Okay, this one operand. This other one is what the 4 bit of 1010. Okay, 1010. Okay, what is the sum here? What is the sum? Sum is in 1 plus of in 2 plus of in 2. That's nothing but the will by performing the these two operands are what the sum and that's the addition operation. Then the result is whatever the result we are getting on, that is also what the unknown value. That is also what the value consists of the unknown value. Unknown value x will be what is the value of the unknown value? What is the value of the x value? What is the value of x value? X value ಏನಿದೆ? ಇವಾಗ what is the value of x value? X value ಯಾವುದು? 0 or 1. Here ಯಾವುದು? 2 value 0 or 1. Similarly, z is also just say both the value are 0 or 1. If I multiply with the any value x, then what the value of the x is, and the if I multiply with the x with the z also, we will get the x itself. Multiply with the z, we will not get the any of the operation on the z, we will not get the z value. We will get the x value itself. Okay, similarly, if I go to the modulus, a is having the equal to 13 and also b is equal to 3. Okay, a is having the 13, b is having the 3. Then I have to go to the modulus operator is for the this percentage value. This is what the percentage. Okay, modulus value. What modulus is nothing but what we have been talking with the modulus 13 by 3. 13 by 3. Okay, 13 by 3. What is the value of this equivalent for the modulus value? Whatever we get here 13 3 4s are 12. Okay, 1. Whatever we get this remainder that we have to call the modulus value. So that we are what the value of this modulus is 1. Similarly, we will go for the 16. Okay, sorry. A modulus of b values are what the a is what the 16. These are the value in the value is what the b is also value the values as the 4. What is the modulus of this these two? 0. Yes, you are right. 0. Similarly, I can go with what the -7. -7 by percentage of modulus of 2. What is the value of this value? Okay, what is the 2 to the power 2 to 3? That's nothing but the 6. 6 minus 7 over 6 is what the -1. The value of this modulus is what the -1. Whatever we are getting the remainder, the value is to consider as the modulus value. Okay. I can go with for the 7 to okay. What here for the bigger value. If I go with the 7 modulus of -2, then the what will be the value of this one? +1, because the which is the operator having the highest priority, that is the value of operation. This size should be given here. Okay, it's for the value -1 because of this 7 is having the this is the highest operator, that's the value, and also sign of that 7 is for the -1. That's what we given the minus plus we given the -1. So that similarly 7 modulus with the -2 is for the highest value operator value +7 is there. So that we go with the plus sign of this one, but the remainder 1 is there. This is what the we have to calculate for the modulus. Here we are giving the examination for the A and D value. Let's calculate the modulus of these two. Here we are asking for the like this. So many examples, so many we will give the operators with the we will give the mix of okay logic. Till now we have seen the arithmetic operators with the binary. Even if we give the unary also, even if we go with for the logical, like this relational, rational, so many are there. We will be studying one by one. Next we will consider what is studied the that's all we know for the binary. Now we go with for the unary operators. Unary means the this is the operator under the arithmetic operators are so these to be operated only for the only one operator on what the how many operators we can be applying that one the value operator to only one to only what how much like you know what the matter Swati what's the matter Ramesh binary operators these are the binary operators. Okay, these we need the two operators. This we need two operators for the unary operator. For the unary operator, these operators only will be using for the arithmetic operators as multiply, subtract, like this, add, this divide, modulus. Okay, for this will be applied to for the now the only single operator. That's the what is unary operators. Okay, unary operators. Okay, if I go with the unary, how will you consider the unary operators? While using these types of operators, I will be easily I can easily write the data flow modeling program. Follow. क्या मॉडल छोड़ते हैं कॉल करो अरे अरे क्लास में यहाँ पर नहीं कर सकता एसएससी ला क्लास में मोबाइल यार पढ़ने डायरेक्ट को मिला मोबाइल वापस एसएससी ला कर पढ़ अरे क्लास में वो मिला वापस में क्लास ओके इधर ऑपरेटर्स ओके दाइरे ऑपरेटर्स what plus or minus can also be called many operators can also be called the many operators unary operators for the plus or minus okay plus side minus okay these we applied okay these are unary operators this to be what is the different types of operators also okay if I go with the -4 what is the value of plus 5, then we can say for the positive 4. This for the positive 5, positive 5. Okay, that's nothing but that we can apply this positive and negative values to all the types of operators also. Okay, for example, if I go with the minus 10 by 2, what is this? This is for the division. This is for the negative of 10 with the division of the 2. Negative of 10 with the division of 2. Okay, this is for the unary operator. Okay, this is for the unary operator. Okay, evaluated to how much? What is the value of this one? Minus 5. Minus 5. Basic logical operators, basic logic gates ಯಾವ್ದು ಅದಾವ? Logical operators. Okay, logical operators in Verilog are what are those? One is for the logical and this is to be mentioned. Okay, this for the logical and. But in Verilog HDL, how to use this Verilog logical and? Only that's the only one MSM is not enough. Two MSM I need here. Okay, and also similarly logical. How to write this logical or single as national double straight lines. Okay, the logical not. Logical not. Okay, logical not. That's to be given with the input for the. Okay, this is for the sentence. Okay, if usually we will be writing the this is also right for this is for the get not get. But if found anywhere in the equations, that is to be considered for the not get. This is the writing the equations, but you writing of the multiplication in the not get with the logical operations. I think this is the example. Okay, operators. Okay, these two columns are the binary operators because we need the two operands there compulsory. I need the two operands compulsory for this logical operations. We can call them as the binary operators. And this is what the unary operator. So what we need only one input as for this one. So that we can call them as the unary operator. Okay, then I go with the logical operators have the some conditions here. How to do it? Either it defeats the my big values for the for example, some conditions are logical operations. Okay, these are the logical operators. We have the three types of logical operators. One is logical AND, logical OR, logical AND. Okay, these are the what the equivalent operators super double. What we call this one? Ambassador. And this one the double statement is because the it's a single These called as the binary operators because we need the two operands over there. For this operation, only not operation, we need what the logical not operation. We need the only one operand. That's what we can call the unary operator. Okay, we have the logical operators. We have the some conditions. Okay, some conditions also. What the condition? If the statement is true, statement is true, or rather it is a true value, then you should have the value as the 1. If it is a false, you should have the 0. If it is an unknown value, that's why you should have the x. This is for the x. Okay, this is what we sometimes call the ambiguous also. And also we have some conditions here. If it is not equal to that's not equal to true. If it is not equal to true, means it's of course it is having the value as the 0. If it is not equal to false, it is not equal to false. ಅದು false ಅಲ್ಲ ಅಂದ್ರೆ ಅರ್ಥ ಏನದ it's a true. That's the one value. For example, I consider the two operands a equals to a double equal. This equal ಅಂದ್ರೆ single equal use ಮಾಡ್ತೀವಿ generally, but in the Verilog HDL we use the double equal for the equal condition. A equals to 2 and the AND operation. That's the logical AND operation. With the b equals to 3. Are they both are equal? No. Equivalent to 1. Equivalent to 1. If both are equal. One way every equal is there, one are equal. Because this one not equal, so the value equal. It's equal to what the 0. It's equal to 0. Just copy this one. I go to the question of some examples. First copy this one. Copy this one. Okay, copy these things. Okay. Copy that. Okay, I consider the one example. Okay, whatever we are studying here, these are not important, but the examples whatever we taking, these are additional examples. These are very very important. Okay. A equals to what? A equals to 4 bit of binary form. That's the 0 1 1 0. B equals to 4 bit of 0 0 0 0. Okay, 0 0 0. Okay, if A is equals to 4 binary of 0 1 1 0 not equals to 0. Not equals to 0. This one not equal to 0 is the full the false alarm. Not equal to 0 value is nothing but it is a condition. What the value of this one is? Value is there not equal to 0 means it should be the 1 ಅಂತ ಅರ್ಥ ಅಂದ್ರೆ true ಅಂತ ಅರ್ಥ. ಒಂದು ವೇಳೆ equal to 0 ಇದ್ರೆ false ಇದೆ correct ಅಂತ ಅರ್ಥ. Not equal to 0 is nothing but equal to 1. It's a true condition. It's what the true condition. And also I have the b equals to 4 bit of 0 0 0 0. This is not equal to 0. Is it right or wrong? True or false? True or false? False or not? Then the it's what the value here. The value is here the 0. Value is not the 0 here. Okay. Then the right the A ampersand of logical one ampersand of logical 0. What is the value of these two? What is the value of these two? 1 add with the 0. How much? Multiply with 1 multiply with what? 0. What is the value of this? 0. 1 multiply with what? 0 is what? The 0. 0 itself. It's equivalent to what the value? Equivalent to 0 itself. This is what we are doing the operation. What type of operation we are doing here? Logical AND operations. What is the value of this? What is the some values here? Let us perform the logical AND is what the some value. If zero value itself. Okay, now consider the A R3. A R3, we can write this one as the logical one. Logical one. This is not a logical zero. What is the value of this one? 1 0. 1 0 is the logical operation. R operation is not. 1 is plus 0. R is nothing but the plus. R is nothing but the plus. So that it is equivalent to what value? 1. It's equivalent to 1. Equivalent to 1. Why? Because the 1 multiplied is not a multiplication. Not a multiplication. This is what the first operation. This is the R operation. Logical R. 1 with the 0 for the value 1 itself. Okay, similarly, I can go with the A. What is the value of A here? 1 is the not equal to. What is the value of the not A value? Logical 1 and 20. Logical 1. Logical 1 ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? 1 ಇದೆ ಏನಾಗುತ್ತೆ? not A ಆಗ್ತದೆ ಏನಾಗುತ್ತೆ? 0. A equal to 0 ಇದ್ರೆ ಏನಾಗುತ್ತೆ? 1 ಆಗುತ್ತೆ. 1 ಇದ್ರೆ 0 ಆಗುತ್ತೆ. ಹೌದಾ? But here I have the logical 1 operation. This is the A is having the logical 1. Now value of this one is what the logical 1 is the other not get apply ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? 1 ಇದೆ ಏನಾಗುತ್ತೆ? 0 ಆಗುತ್ತೆ. So that it's equivalent to what value? It's equivalent to equivalent to 0. Equivalent to 0. Like this, I can go to what the asterisk B. This is what the logical 0. What is the value of this logical 0? 1. Yes, you are right. Logical equivalent to 1. Equivalent to 1. Okay, this is what the use. Okay, this is how we will be using. Next, we will go with the relation operators. Just to copy these things. Copy the. relation operators. Okay, relation operators are what are those? Greater than, forward, this for the backward, and this will for the greater than or equal to, for the less than or equal to. Okay, so the operators. Okay, relation operators are used very important in the expressions in order to do the relation whether it is greater than or equal to. We are doing what the comparison here. We are doing what the comparison operations between the two values. Okay, what we are doing the comparison between the 1 and 0. 1 and 0. Which one is the like the higher value? Which one is having the lesser value? Okay, the relation operators usually have the values 1 equal for the 1, that's the true value, 0 for the false value. So my upper is having the unknown value, yes sir. Unknown value then I go with for the x also. Then I go with the x also. Consider the one two examples. A equals to just to copy that one. If I have the consider the one two example for this. A equals to b, a equals to 4, b equals to 3. A equals to 4. Example, A equals to 4. B equals to 3. B equals to 3. A equals to 4. A equals to 4. B equals to 3. X equals to 4 bit of 1 0 1 0. Y equals to 4 bit of 1 1 0 1. Z equals to 4 bit of 1 x x x. Okay, now condition is here. A is equal to, will be given in the examination. A is less than or equal to. Whether it is that true or false? False. False or true? So that you are rated to what the value? You are rated to false. That is the 0. You are rated to 0 because A is not less than or equal to B. It's false. Not a correct value, correct condition. So that you are able to what the value? 0. Similarly, A is greater than or equal to B, greater than B. So if I case equality, I go to the 3 equal. Okay, if you say case equal 3, same go to the. Okay, another is for the case inequality. Say 1. When we use this type of expressions, equality operators, return logical 1. Is that true? Is that true? We have this type of return values are the 1. Is that true? We can have the values of these operators equal to 0 if it is a value condition for the false. Or false. The logical operations for this one is if the conditions are true, then the return value for the return value for this logical operation for the equality operations for the value is 1. Similarly return value is 0 if it is a false. If it is a false condition. If it is a false condition. If the conditions are true, then the logical return is for the equality return value is for the 1. If it is a false, then the returns the value as for the 0. This is the 0 here. For example, the x value, and even it can also have the value as the z itself. So in such a situation case, we will have the a equal to the either is if it's the condition is true, then we go with the 1. If the condition is false, then we go with for the 0. ಹೌದಾ ಉಮಾದೇವಿ okay, a is not equal to b. In that case, it's including what the if a value is what the x and even the b is also having the x or z value, then also it is inequal. That becomes for the case inequality. In such a condition, we have the two values either 0 or 1. If it is two conditions, then we go with what the value output value is for the 1. If it's a false, then we go to the value as the 0. These are what we call the equality operators. Okay, one we will consider the one example for each. Input values variable x or z compulsory. If it is not, here my conditions, my variables I am considering what is that x and y is not having the both are not having what the value here x or z both are having the binary value. Just to check it out, the x is having the value as the 1 0 1 0 yes sir 1 0 1 0. Y is having the value is for the 1 1 0 1. Both are not having the x or z. So that my case inequality is what the false. My case inequality is what the false. Then the what it will return in the value as logical 0. If it is false, is what the returns what the value here? Returns the x value only. X value results for x value. Z equals to m. True or false? Z x m x. So that values where the results the logical as true because logical 1 because it is written because the both are having the x only. Both are x. M is next condition is m is not equal to l. True or false? M is not equal to l. Is it true or false? Yes. Because m is not equal to not equal to l. It's true. Both are having the its z value. This is here the x value. So that it's the logical one. Okay, next we consider the bitwise operators. What are the bitwise operators? Bitwise negation, bitwise AND, bitwise XOR, and bitwise XOR. Okay, these four operators will also see. Still I have the 10 minutes. ಇವಾಗ ನೋಡ್ರಿ ಯಾಕ ಸೌಂಡ್ ಯಾಕೆ ಮಾಡೋರು ಹೇಳ್ರಿ ಇವಾಗ ರೀಸನ್ ಹೇಳ್ರಿ ಯಾರು ರೀಸನ್ ಕೊಡ್ರಿ ಸಾಕನ್ನೋರು ಹೇಳ್ರಿ ಯಾರು ಸಾಕನ್ನೋರು ಹೇಳ್ರಿ ಹಾಂ ಗಾಯತ್ರಿ ಸಾಕು ಮಾಡಂದ okay third hour also will be the DSDV class. Okay.